Number 3.
Water can be made to decompose into its elements by using electricity according to the following equation. Remember, this is called electrolysis. Electrolysis. Electro, as in electricity, lysis, meaning splitting. Right? Anytime you see this word lyse, right, and not lice like the bug, okay, no. This kind of lysing, it's a splitting, it's a cutting, okay. Snakes are actually categorized into what type of venom they have, whether or not it's cytolytic or protolytic. And so protolytic, you're going to be splitting, you're going to be cutting proteins, and it kind of that venom denatures the proteins in your body. That's how it breaks down your body. That's what's dangerous for you. Cyto is a base that means cell, so it's cell splitting. It's actually breaking apart the cells that that venom comes in contact with. And so that means splitting. Electrolysis, electrolysis, that's the splitting of something, in this case it's water, by the use of electricity. So here's the balanced chemical equation. If you don't trust me, you can check that on your own. How many grams of O2? How many grams of O2? So this is an unknown, and it's a mass, are produced when 0.033 moles of water, so here's a mole, of water decompose. And so this is the known. This is the given, using the same language that your book uses. So this is the mass to mole. So far we've had a mole to mole, we've had a mole to mass, now here's a mass to mole. So we're still going to use a mole ratio and a molar mass. However, in this problem, we're going to use the molar mass first, and the mole ratio second. All right, so let's start setting it up. We're starting with moles of water. All right, that's our given. Let's see, did I say that backwards? Goodness gracious, no, it's the same order as this one. I'm sorry, I misspoke. All right, moles to mass, moles to mass, moles to mass. My bad. I got you excited for no reason. Well, I'm going to cancel out of moles of water, and I'm going to go into moles of my unknown, which is O2. But I need that to be in a mass by the time I'm done, so I'm going to go out of moles of O2 into grams of O2. And please remember that oxygen is, in fact, a diatomic molecule. So when you calculate this, it's actually the mass of 2 oxygens. It should be 32 grams per mole. Now, what numbers do I plug in for this mole ratio? What is the number in front of that O2? It is a 1. What do I plug in for the moles of H2O? What is the number in front of that H2O? That is a 2. Moles of H2O that are actually decomposing. Get that from the prompt. It looks like we're ready to calculate because moles of H2O cancel, moles of O2 cancel, and the only unit I have left is what my answer is supposed to be in terms of grams of O2. So let's do some calculating. I'm going to go with 2 significant figures right here because that's what the question has given me. So 0.033 times 1 times 32.00 divided by 2 divided by 1. So I want 2 significant figures. This actually has 3 in it right here. So I'm going to get rid of this last digit, and it's going to roll this 2 up to a 3. So 0.53 grams of O2. 0.53 grams of O2. Hooray, with 2 significant figures.